Hello everyone, and welcome to another video on the ClubFoot escapement. I've added a fork assembly to the escapement for those who wish to take it to the next level. And all you have to do on the dialog is you check this box, add fork assembly. Now this is a typical lever escapement fork and impulse pallet arrangement. I've arranged this so that the impulse pallet is on the same shaft as the ratchet, just for ease of use, but it's not necessary for you to stick with that. We have a couple sliders up here for distance. We can move our fork and impulse pallet to a new position if we like, and we can also rotate it to another position. It will work in any position, so it's unimportant where you put it, but this allows you some flexibility to put it in a place that fits the overall design of whatever kind of kinetic mechanism you're trying to make. I've limited you to a distance equal to the shaft-to-shaft distance as a maximum. It gets a little bit, the math gets a little bit out of whack if you get too far away. But you can rotate it to any position within a circle of that radius. Now let's take a look at how this works, just so that we have a full understanding of it. And I'm going to start by pointing out that I have not connected the fork to the pallet. This is left as an exercise for you when you're done. Just quickly, in order to do that, if I hit OK, I'll get this as a drawing, and I can now take my scissors, and if I intend to use this thing, I just simply clip out the parts that don't join, and now we have a working fork and impulse pallet arrangement. All right, let's go back to our design screen. We'll delete that and bring up our ratchet again and hit a regen. Now let's hit simulate and just take a look at how this works just quickly. Now in this simulation, of course, there's a weight on the ratchet wheel which makes it want to turn clockwise. The pendulum is hanging off of the center of this impulse pallet, and you can use gravity, or you can have a wheel like in a watch where you have a recoil spring moving a larger mass wheel on this back and forth. But it works just as well with a pendulum hanging on this central axis. And the whole point of this escapement is to transfer energy to the pendulum without causing any friction or touching the pendulum when it's not receiving energy. So I'm going to slow down this simulation, and I'll show you what the explanation of the impulse pallet is. We'll take this down to very slow, and we'll stop it right here for a second. This pointy bit is normally glued on top of the fork, and it's called the dart. And the dart's job is to make sure that no one can bump your clock and get it out of sync when it's not supposed to be moving. In other words, the only time that this rocker is allowed to free a tooth is during the time that this impulse pin here is within this slot on the fork. So if we let the simulation run a little bit, if you imagine now someone tried to tilt this rocker, they would have to tilt it upwards to a point that the bottom of this tooth reaches the top of this tooth before the ratchet would be free to slip. But before that could rise enough, this dart up here would hit our safety disc. So this is a lock during normal swing of the pendulum to make sure that this tooth cannot release through vibration or through being bumped. There is only one time that the dart can pass high enough up for these teeth to miss, and that is when the dart is inside this crescent. There is a time, however, that the dart is free to move, and we'll just hit simulate until we get to that spot. You have a sim speed button here at the bottom. Now at this point here, our dart is pointing at our crescent, but it still isn't time yet for this tooth to be released. That shouldn't happen until our impulse pin hits inside this power delivery slot. So these horns on the side, this is called the left horn and the right horn. Their purpose is the same as the dart on the safety disc. If this tooth tries to bump upwards to free the ratchet, this horn would hit our impulse pin and stop that from happening. The only time that this tooth can now bump up is when the impulse pin reaches the slot. So these two working together, the horn and the dart, are a safety mechanism to make sure that your clock cannot improperly release a tooth. One of the benefits of this is that once the driving pin passes the slot and clears the horns, there is no touching of anything to the pendulum until it comes back and the impulse pin strikes the slot. And if we watch that come in, you can see now that the impulse pin is entering the slot. At this point, the dart is free to move into the crescent, and the horns are no longer restricting motion of the lever. This tooth is now allowed to clear. So what will happen at this point is that the leading edge of the pin will start to push on the fork and begin a tilt. But as you can see, the tooth here is now starting to push upwards on the pallet tooth. This will cause the back end of the slot to push on the pin. The angle is calculated here to be plus or minus 14 degrees from the tangent of the wheel. This means that power transfer is optimized at this point with the notch pushing on the pin. This will add energy to your pendulum to allow it to come back and do the inverse on the other side. This way your pendulum has energy added to it on each direction of swing by the energy of the flat of the ratchet tooth pushing on the flat of the pallet and flipping the index pin to give it energy in either direction. So at this point the pin is pushing, the back of the slot has pushed on the impulse pallet, the pendulum has gained energy, and it will go until it runs out of energy, at which point it will reverse direction, and the entire process will repeat using the two teeth on the other side of the pallet. And if we watch it come in, dart is now released, horn is inhibiting, pin enters slot. We begin, the tooth are now pushing, the back of the slot would push the pin, and the pendulum gets energy to continue on the other direction. So that's it. That's how a lever escapement is supposed to work. By moving these things around and hitting OK, you can select a drawing which gives you all the proportional parts necessary to build a proper lever escapement. Thanks for watching.